So I'm wanting to move on to elf symbols and relocations, but before I can do relocations, I just realized that my fixup implementation in the encoder, where it records the offsets and sizes of fixups and things, is actually destroying some data that I actually need to encode the instructions properly. So right now, the fixup function here basically takes an operand and then it just marks it with this fixup sort of like decorator attribute thing here. And this is what the encoder will use to basically update like the offset of the fixup and things like that in this fixups slice here. So this fixup ID is just the index into this slice, and then we use that to index into the slice to set the offsets and size and stuff. The problem with this is that I'm completely destroying this value here, where the value is actually used to do things like getting the registers that are supposed to be used. So if I go to my main function here that I've been using to test, and let's just add, for example, let's just do something like load effective address. We'll do, let's say, keyword. And then we'll load effective address into something like CX, and we'll just say that we want an encoder fixup that we'll just call foo. This will be fixup, let's say branch, or fixup memrel, let's say. And this will be, for example, ip.m, so it will be a rip relative displacement. Now, the reason for passing this operand in is so that it can match the same instruction form as it would do if I was passing in the operand directly like this. But since I'm destroying the value, this will basically get rid of any register information and it will encode the wrong bytes. So let's just run this. And we use objdump again. So I think this was mintel, and then we'll get the disassembly for testing.o. And so we can see here that it's encoded Leah properly, and it's got the CX register here. But instead of doing a rip relative memory displacement, it's doing RAX instead, and then these displacement bytes here are coming out as add instructions. So to fix this, basically I just need to keep the lower 32 bits of the value, because that's where I store the register selection and stuff. And instead of storing the fixup ID, which is the index into the slice, in the entire value, I'll just shift it up 32 bits, which is where the displacement would normally go. And when I need to index into the fixup slice, I'll just shift it down by 32 bits to get the index. So if we start by going to the encoder here, we'll just create a new position. So this will be like a fixup ID position. So this will be position 32, and it's going to be these bits up at the top here. We'll also do a fixup ID mask. So this is going to be the same as that, sort of like the example mask here. So this will be shifted up by the fixup ID position here. And then when we create a fixup, I guess what I should do is actually, before setting the value, I should unset any displacement that might be in there. So we'll unset the fixup mask. And then here, we'll basically take this fixup ID and shift it up by the fixup position, and we'll OR that with whatever the current value is. So let's try and run this. Okay, so now I need to shift down when I'm indexing into it. So we've got an index into the fixups here, which is just rm value. This will now be, actually, I think maybe what I will do is I'll just have a fixup site pointer here. And we'll just set this to the address of this, shifted down by fixup ID position. Then I can just use this everywhere instead. So we'll do this down here if fixup is not nil. Okay, so let's run objdump again. Okay, and so now we're getting this CX load effective address, but this time it's correctly encoding for a RIP relative memory displacement. But the other thing about this, though, is that I'd realized that I'm storing the displacement from RM here. And this is generally fine. It is used in here, but this is only if it's no base and it's not vsib anyway, so this is fine. But down here, disp is actually used to calculate whether we can use compressed displacement for evex instructions. And so if this is 0, or if the displacement that comes out happens to be something that would divide cleanly and allow a compressed displacement in evex, this would actually encode the wrong bytes. So I need to make sure that I'm only coming into this if we've got a tuple type on the form, and RM is not any of, well, I suppose relative, so RIP relative will always be disp32, so we don't want to do compressed in that case anyway, but we also want to make sure that it's not a fixup. Let's just try this again, just to make sure. That's all still okay, and the tests are still okay. Let's just do bench as well, just to see what's happened here. Go test bench. Okay, so this has actually gotten slower now, but I only changed really the fixup. I mean, I did change something in here, but that was like a pointer thing. I wonder if this is just like a code layout thing, maybe? Let's put this down here. Yeah, so this is now much faster again. So I guess this being down here has made the Go compiler rearrange the code in such a way that this is actually faster on this CPU. I'll just put this back here, but that does explain it a bit, so let's just see this again. Okay, so it is a bit slower, but these are already in the 5 to 6 nanosecond range anyway, so small differences are going to make a pretty big difference in the number of instructions per second at this point. So anyway, that's the fixup change that I wanted to do, just so that this is ready for symbols and relocations in ELF relocatable object files.